In this video, we're going to be implementing a design for an aircraft. Aircraft, they have three gears. You can see them here. All right. Two on the side and one in the front. And before landing, these gears need to be extended, and pilots need to know when that really happened. So we want to have some diode, some LED that indicate when everything is okay. What this mean is when this one is fine, this is okay, this is okay. When all are okay, then we should have a green light. If any one of these, okay, any one or two, if anyone, okay, is not functioning, then we should have a red light, give us warning, things are not okay. Not okay. All right, and for this design, we're going to be using a NOR gate. So let's recall how a NOR gate works. So in order to understand NOR gate, we need to understand the OR. And the OR gate has two input, A and B, and they have this kind of, I'm going to draw it here. So they have this kind of symbol, okay. This is A and B. You know what, let's draw a better one. So yeah, so yeah, it has this kind of configuration. So this is A, this is B, and this is the output. So we can understand the behavior in terms of some truth table. So when both are 0, the output is 0. When one is on, then the output also on. When both 1, the output is 1. Okay, so this is the OR. Now the NOR behave the opposite. So I'm just gonna go here. I'm gonna get different color. So when both, so we're gonna see the opposite of this one. So this one is 0. Okay, and it's gonna be 1. And if we draw the diagram, which is exactly this guy here, it is a OR with circle in the front indicating the NOT. This is the NOT. So here A, B. So you can see the opposite of this. So they're going to be here 0, and this one going to be 1. Going to be 0, 0, and this 0. So you can see it here is only on when the input, when both are 0. This gate has an equivalent which is called negative AND. It's called negative AND. You can see it here. So it's just an AND, okay, with two input, but the input are negated. So this one is exactly the same. This is equivalent. Those symbols mean equivalent. This is equivalent to just the NOR. Both of them are the same. Both of them behave the same way. So basically, they are functionally the same. But if you are curious why being connected this way is this for a practical reason. All right. It turned out if you are looking for stable input when you have some when you have high when you have some certain input, some of these are better represented using either of these. So it's just for engineering thing. I don't want to get into some detail to distract us from the subject matter. But just keep in mind that they are exactly the same functionally. For practical reason, it is good idea to connect the NOR to the cathode and the negative or to the anode, just for practical reason. But functionally, they are exactly the same. So we're going to go ahead again to Falstad, and you can find it as falstad.com, and then go and open the file, and you can download it from the course website, or you can design it from scratch. It's not really a big deal. So here's the figure 3-40, double click, and you will see it here. All right, maybe for a better view, you want to toggle to full screen, bring it here. Okay, the center, you can do that. All right, so let's do some simulation here. So here, so these three input again representing the gear. These are the side. This is the front. So what this means, everything is fine. All right, so the gears are extended, the aircraft is okay to land, and you can see the flow of electrons moving on this diode, and this diode should be, this is the green, should be on. All right, that means everything is fine. Okay, however, if something went wrong, let's say one of them, all right, then this is the orange or the red that indicated things are not okay. So when 1, 2, or 3, so that means nothing, they are not fine. It's only when all are low, they stop indicating any lights, and the green light signal that the aircraft is ready to land. So download it, play with it, and again, this is, you can see here the resistors. Maybe the only thing that we didn't discuss in this course is little matter that affect the performance, but typically and because diodes and transistor only take very small amount of voltage, so we need resistors to make sure that they function well.